to Electrician Live with your host, Paul Abernathy and Jay Grunberg.
Well, hey everybody, welcome to another episode of Electrician Live, where we talk about all things electrically related. And tonight we got a great show, but before we even do that, we got to say welcome to my co-host, Jay Grunberg. Jay, thanks for joining me again.
What's up, everybody? Hey, Paul, how's it going?
It's going good. Glad you could join me again. Again, I guess we're picking up part two, kind of picking up a second part. We talked utility, 30,000 foot view, kind of gave some topics in there that last week's episode that probably confused some people. Again, I have a tendency to do that, but we're going to dig more into, I guess, the residential aspect of that this week.
That's right, man. This is my wheelhouse. This is what I do regularly. So I'm excited for this episode too. I've been doing some study on it, especially with the new code coming out. Again, we're not going to get too cozy on you guys, but we do want to incorporate some of the important additions to the 2020 code, because again, you guys are electricians just like I am out there in the field, and you got to know this stuff, and we're going to give you the inside scoop on a lot of the good details of what's going on, and you can use it out in the field. So I'm excited, Paul.
Yeah, I start getting overly cozy, we're going to have Jay just reach out and grab me.
That's right.
Because
Brilliant.
again, we only have an hour. Yeah. And so again, I could probably go into every little nuance of point of attachments and straps and securing and cable types and raceway types and through the roof penetrations. And
sure,
we only have an hour. So again, we're very aware of your time, and we thank you for taking the time to be with us, but we have to be very good stewards of that time and try to touch the levels. Of course, y'all all know that I teach code over on my channel anyway, so we'll talk all kinds of code topics. But today we're going to try to cover a lot, because I really want to dig into some of the stuff we deal with Jay's insight when it comes to once we get in that dwelling, once we get to that panel. And again, I'm always intrigued because, again, service upgrades and things like that, or even the services, again, it's all a timing thing too, right? So putting in the timing, but we're going to dig into that. But I guess before I do that, we got to pay homage again to our sponsor, which is Electrician Pride, for all of our neat stickers and stickers. Jay's got some on his books there. He's got his shirt on. He's got his wizardry shirt. He likes that one. And, I think, that wizard kind of looks like me. And then, of course, he has his mug that he's been drinking all kinds of beverages that we probably shouldn't talk about. Yep, he's going to say no, but he has. So let's go on and do that, and then we'll get to the show. Today's show is sponsored by electricianpride.com, your one-stop shop for electrician-specific T-shirts, hoodies, phone cases, mugs, die-cut stickers, leggings, and so much more. Featuring unique designs for electricians, journeymen, and master electricians, as well as electrical engineers and electrical inspectors. For more information on all the products that are available, visit us at www.electricianpride.com today. All right, so again, all your good stuff, shirts and mugs and phone cases and all kinds of good stuff there.
Leggings, I haven't ordered those yet. But
yeah, you need some leggings, man.
I was thinking about it. Once that came up, leggings, I was like, very curious.
I need some leggings.
Am I an electrician or what? What the heck?
No, man, don't be hating. They can wear leggings if they want to wear leggings.
That's right, man. Get all the good stuff. Check that website out, and I've shopped there before I was a co-host with Paul, and I was able to pick up some cool stuff. It's good topic conversation too with your fellow workers. But let's dive into it, Paul. I'm ready.
All right, sounds good. So we left off and we were talking about utilities, and we were talking about once it gets to the transformer at a pole or a pad mounted transformer that's at your property. and we're going to say that it's either 7.2 or 2400, depending on your utility, hits a transformer, and now it's going to change over, and it's going to come to the side of our building. Now, we're talking residential on this show, so we know we're going to be 12240. It's going to drop down to the side of our building. Now, as we talked about in previous show, if it's a transformer that's on a pole, then that's probably going to be a service drop that comes down to the point of attachment that secures to the side of a building. Or it's going to be a utility transformer on the pad that is on the property, and it's going to go underground. That's called a service lateral, and it's going to come up into the meter. That's your typical, right there, residential application.
Yep.
Now, interesting enough, the service lateral and the service drop are technically outside of the scope of the NEC, even though they're covered in there for our definitions. But again, the depth of cover and all that kind of stuff and the clearance overhead typically falls under the National Electrical Safety Code. But it's in the code because you could have some applications where they are considered service conductors overhead and things like that, or underground service conductors, and then the code's going to come into play. And we're not going to rehash that. That was done in the end of last episode where I totally confused everybody. Go read those definitions in the NEC under Article 100, and you'll get a better understanding because it's pretty clear. Pretty clear. But let's get to the building. This is where Jay lives. You know, as a residential guy. He's at the side of the building. Now, Jay, we talked about it. Once we get to the side of the building and we have what's called a point of attachment, that's where the service drop, let's say, we'll do overhead because in your area, majority of things are overhead. If it's a lateral, it's pretty darn easy, right? It goes from the transformer, goes underground, comes up into the meter, you're done. But you do a lot, so that's pretty simple. So we won't get too detailed in that part of it. That's pretty decent detailed. Utility usually takes care of that.
Well, and again, in my jurisdictions here in Colorado with Excel, which is our POCO company, power company, is they allow us to disconnect that meter. So if it's going underground, underground service lateral, or an overhead service drop overhead, I, as electrical contractor, have all power to cut it off live. I don't need to wait on them to come out and disconnect it. So you get to make that ultimate connection from the utility, that point of attachment, that line of demarcation. You're the one, so you might not have to wait as much on somebody, whereas me in my area, I couldn't touch any of that stuff. So I had to coordinate this with the utility company and everything. So again, every area could be different, right? Yeah,
so,
and which is nice about allowing the electrical contractor to disconnect the old service so that you can upgrade the new one, because you don't want to upgrade it hot. You don't want to upgrade it live. You want to disconnect the utility side of it, whether it comes underground. Now, the underground ones are a little more scarier because, again, if it's overhead, you go up on your ladder, clip, tape them off, drop it on the ground, you're done.
Right.
So underground, you're dealing with these things live, and you have your Allen set and a ratchet, and you tape it up, or you get an insulated set. Again, for me, I do it a certain way, and I'm wearing gloves when it comes underground. And
PPE, people. PPE,
yes.
protecting yourself. Okay.
The underground ones are a little more scarier just because I can't just clip them. I have to.
You mean you don't go out and open up the transformer and cut it there? No, I'm just playing.
No. They got a special tool to get inside those transformers, and I've never got one of those special tools, but so we actually disconnect our own live, and then we have to do what's called a closed loop. So we'll actually have an inspection. We'll pull permit. We'll cut their wires, either underground or overhead. We'll do our service change out, which we'll get into of the how we do it, and then once we hook it back up, we call an inspector out maybe the next day. So what's happening? I don't need to have an inspection pass to get
power back on.
And even if I get hit with a couple corrections, they still have their power back on. And the corrections that I get hit with are so minor. It might be a strap here or there or something.
No. Wired up Electrical Design LLC does not get hit with any violations.
Any violations, right?
No, it's Code Strong, baby.
That's right.
They get none.
But all those Code Strong guys.
Right. So that is quite interesting because in our jurisdictions, and power is not going back on until after it's inspected. And
Wow.
so, that
You
type
have to
of
do it all
thing,
in one day.
all in one day, all in one day. So the way we had to do it was we'd have to coordinate the utility coming out, pulling the meter.
Yep.
If it's a service change, we would have to coordinate that. We'd have to coordinate the inspection because again, if we're going to pull it at early as we can, while people are able to get out of their house. So we might do it at 7 a.m. and coordinate it. Utility, try to get them there. Get it pulled. Schedule them to come back the same day. Schedule the inspector to come out after we're done. Might be 4, 5, 6 hours later, depending on the service change. And to be able to coordinate the actual to all finish in that day. Him or her to do that inspection, and then to be able to call in. And usually in Virginia, what they do is the inspectors call the Dominion Power or something, and they'll say, "Okay, it's completed, it's done."
Right, they're
And
doing
then,
like a meter release.
Yeah, and then they release it, and then the utility will. There's a person that just rides around that does nothing but meters. Will come back out there, put the meter in. Okay. That type of thing, provided that the riser or what's going up to the weatherhead or something didn't need to be replaced. Or again, if it did, then they might have to come out with the bucket and then they got to make their connection again. But yeah, we used to do that all in one day and we had to coordinate it the whole day. And it was a pain. Okay.
That's a lot because you have to get on their schedule too. Because these power companies, sometimes they're weeks out.
Yeah. And you got to get on the inspectors because sometimes they can be case loaded. And they have a problem getting there on time, especially if they're behind. And so, and you're just trying to cut the power, do the change, and get it back on for the customer. Whereas we can't throw the meter back in there. So if something screws up with the utility or the inspector can't make it, those people without power overnight.
Oh,
so there's a lot of stress involved in it.
Yeah, that's not good. That's a lot of food damage. You're looking at maybe cars not being charged. There's a lot of factors in there if you can't get their power back on. No heat, no lights. Yeah,
I'm sure there's people out there that will jumper stuff and make stuff happen in order to be able to get things back on again. I bet we never did, so that's what we had to do with it, and we were pretty good. But again, there's so many different jurisdictions, and there's power companies, and they might have allowances. I just didn't get that luxury. But I like your concept where they'll let you get it back on and everything. At least it gets the customer back on. So again, as an electrical code guy, I cringe a little because I'm thinking if they didn't install the panel right, or they didn't do the bonding right, or didn't something right at the service, they didn't do what they're supposed to do. Here we are putting power back on it. But again, it's a convenience thing, I guess, and y'all have provisions for that. We just didn't have those provisions. It was a more of an ordeal to schedule it for us.
Sure. When I first started as a new electrical contractor, I did try to schedule, because again, when you go up there and you cut those lines, whether it's underground or you're disconnecting it, overhead, or you're disconnecting underground, there's that fear factor.
Sure.
There's that fear factor of, I don't know what's on the other side of this. Yes, it's a smaller gauge wire than what I'm used to dealing with, but there's no breaker I can go turn off. There's no fuse I can pull out. There's no really safety protection for me or my guys. So yeah, I did schedule a couple times, but then after I got comfortable with it and talked to some of the Excel guys about the proper PPE that they use, and their allowances, yeah, we just went ahead and started doing it. It's just much easier for us to, like you said, hook it back up, get the customer power, have it inspected the following day, and then I have to call into Excel and do a closed loop, which tells it, hey, I've messed with your meter, I've clipped that little meter
little tab,
number
little
tag
meter
on
tab.
it that everybody.
I told you a story. I told you what happens when in Virginia when we would clip those meter tabs, and back in the early days we'd have to get really creative, okay, with these little ones. But then they came out in clear, and you couldn't get creative, okay. Because sometimes we do a service change, we'd get permits, but we pull the meter. But I mean, I don't want to say we never did things like that, but we would be able to be creative. And then of course it got to the point where they would tell us, you by no means can pull our meter.
Yep.
And that made it a little more complicated,
Oh yeah.
Definitely. Definitely made it more complicated. So,
And I know you guys out there, you guys have seen it. I know you guys have seen the meter tag at your house. It might even be clipped at your house. Go check it out and see if it is. And
just
let
don't cut it off unless you're in Colorado and they give you permission to do that. All right, so Jay, let's talk about now. So we're at the building and we were talking, and typically in Colorado, most of the services that are coming to the actual building are going to be overheads. So they're going to be probably service drops coming down. You know, that's typical. They usually utility will take care of that. That's covered in their service from the transformer down to the structure. So they cover that. Now, there's two ways to deal with the overhead, and we'll mainly focus on overhead because underground's pretty darn easy, right? You just go from transformer underground into meter. Overheads can be a little more complex, more things for people to learn. In your area, Colorado, very prominent, but I also know in Colorado, they have a lot of storms, a lot of snow, a lot of ice. All of that can play havoc on overhead, whereas in Texas, majority of our stuff, main stuff through subdivisions are underground. Yours, everything is overhead. So you were telling me that the majority of your installations you do is the meter outside, it goes up and you have overhangs. So yours go through the overhang and it'll protrude above the overhang, and the code has an allowance for that. Above roof applications in the NEC gives you provisions, and you go through it. Now, you were telling me that your locality, they want you to use what as that rise that goes through the roof?
Sure. Yeah, they want us to use a rigid metallic conduit. They want us to use a 2-inch stick of conduit going vertical through the roof, through the.
And you'll put a seal. You'll put a sealant on it, a flashing boot.
Oh yeah, I'll put a boot on it. Again, most Denver applications are overhead. My house here in Centennial is underground. The newer developments, I think, are starting to go underground, where even the POCO will run their own underground conduits. But the ones that we do overhead, mostly in Denver, we do a vertical riser with a 2-inch rigid metallic conduit through a flashing, and if we go above 3 feet, we still secure, even though it's rigid, I'll still secure it with the guy wires.
Okay.
And yeah, so
well, I mean, y'all have loading and ice. I mean, y'all have all this other. So I mean, the code might say that it has to be adequate strength or guy wires. Again, you can always go above and beyond code. Yeah. And I wouldn't expect anything less, folks, from wired up. Supertritions.
Come on, that's what
there
we are.
There you go. All of us out there, the supertritions. I'm just an old guy, but the young guys, supertricians that are actually doing it. I have my haters who say the reason Paul teaches is because he can't do it anymore. Well, I think you need to get me in a building. This old crow can still do a little work, but I'd rather teach it. To be honest with you. It gets 100 and some degrees out here in Texas, so I'd much rather teach it in the air conditioned than I would be out there installing it. But Jay, they're jamming it down. Colorado's probably not too bad. So,
bad, man. Beautiful.
So we go overhead. The point of attachment, the service drop connects to the actual riser that's going up through the roof. Your case, rigid. And in some jurisdictions, like us back in Virginia, we were able to use IMC or rigid. It allowed us to use either or when it went through the roof. Anything else they wouldn't consider adequate strength. And the code says adequate strength, but the National Electrical Code doesn't really say that it has to be rigid or IMC. It just says it has to be adequate strength, or it's got to be secure and supported and attached to guy wires or braces. Okay? Yes. We'll let your jurisdiction determine what's considered adequate. How about that? We'll leave it simple. Let them do that. But if you go with rigid, you can't go wrong. If you're going through the roof penetration, if you're going with IMC, if it's allowed in your area, it's pretty tough stuff too. Can't go wrong. Typically, I've never seen them allow EMT, that type of application. Just haven't seen it. Okay, but check with your local jurisdiction. So Jay, what we've got at that point, that's a unique application for yours where the raceway would then have the conductors going in it down to the meter. So we have other applications. What if we had a building where we're actually going from the meter and running up the side, but we don't need to go through an overhang because the building's high enough? Because the only reason that we went through that overhang is because we have to get the conductors up high enough.
Sure.
If I could run it up the side and stop it at the eave and put the weatherhead there, then I wouldn't need to go through the overhang, right?
Sure.
And if that's the case, I can run products like EMT, PVC. I could run PVC jacketed MC, to be honest with you. And in fact, the National Electrical Code gives us a laundry list of different types. So check that out. 230.43, I believe, of the NEC allows you to check it and see what types of what that you want to use. But I would venture to say that other than in Jay's application, around the country, one of the more prominent methods of doing this is just to use SE cable. Sure. And that is basically SE, and it's a style U. Basically, it's 3 conductors. 2 conductors side by side, and then it has a helical wrap of bare that's inside of a sheathing. And then when you get to the end, you take the sheathing off, and you take all the strands, you bring them up together, and you make it into its own conductor, and that's your grounded neutral conductor. So it's 3 conductors. That's probably what I see the most. In most residentials, that's what I did, But there was that rare occasion where it would, I would run the either PVC up, or I would run EMT up, or I would run, very rarely ever would I have used rigid or intermediate unless I, again, was poking through the overhang. I mean, it seems like that's just too much to want to mess with, especially if I have to put a bend in it. So if I have to go up and then turn with the eave or something, right. If I'm not going to penetrate, there's no way I'm going to use rigid. I ain't going through all that heartache to do that, right? And if I can use that C cable, I'm going to get away with it, because it's rated for use outdoors, above ground, good to go, okay? So we have an attachment that has to be made to the building, okay, for this service drop.
Yep.
In your case, you're making it to the top of the actual riser that's going through the rigid that's going up there. It's got a clamp, and it'll connect to the top. And in my case, we'll use you as the conduit guy, or use me as the cable guy. I would run mine up the side, and I would put typically an eye bolt or something that's into the wood or the framing of the structure. In order to be able to have that service drop, you have the neutral, which is typically going to have a steel core, and that's going to support your weight. It's called a messenger, even though it's inside of aluminum. And typically, you're going to use aluminum for this. And that would connect to the side of the building. And it would make a connection to the eye bolt. That was my point of attachment to the building. So the code has rules about that as well. So it can't be less than 10 feet from grade to that point of attachment. Now, could it be higher? Absolutely.
Of course.
Might the code require it to be higher because of a drip loops that might be too low? Absolutely. So that's a moving target, but it's got to be at least 10 feet. We know that.
Yeah, okay. And for us using for my example of using the rigid conduit going up, we would use a point of attachment that's just like Paul was saying, it's like an eye hook, but it would be it would clamp around our conduit, our 2-inch rigid conduit. You'd have an open end on the backside. You'd flip that open end up. For those who are on the podcast, bear with me as I explain this. But it would straddle. It's almost like a water clamp, a large water clamp.
Sure, it goes around it.
It goes around the conduit, and you put it and you bolt it down, and you tighten those bolts up, and then from that porcelain eye hook, you would put what we call a wedge clamp on it, and that messenger cable, you'd bring that messenger cable through the wedge clamp, kind of like it kind of works as a Chinese finger where it pulls against it, and the more it pulls, the tighter it gets. But you'd pull that messenger cable as tight as you can, because the tighter you get it, the higher it raises up. And again, like Paul said, at that point of attachment, you can't be lower than 10 feet. 10 feet's the minimum. So if you're at 9'10", you have to pull that sucker a little tighter, or you got to take that point of attachment and raise it up a little higher.
Mitch means you got more guy wires, Mitch, in your case, and it's got, so I mean, it's just, it's code is code. It's a minimum standard, but we have to maintain the minimum.
That's right.
And so, one thing I will bring up is, to help support those out there, obviously not on the podcast, but the ones that are watching. You heard Jay make a reference to his through the roof or above the roof application. Typically, conductors that run over a roof have to be a certain height above the roof. However, with that overhang, since you're making that transition, there's some allowances, or we should say exceptions to the general rule that Jay is utilizing when you go through an overhang. So if we go to the code and we look at that, you'll see what Jay is talking about is going to actually be exception number 3 in 230.24a. So the general rule for through a roof, and I figured I just want to cover it for you folks, is conductors shall have a vertical clearance of not less than 8 feet above the roof surface. Okay? Very hard for Jay to do in this through, where he's penetrating through an overhang to do this. But again, typically 8 feet above the roof. It says the vertical clearance above the roof level shall be measured for a distance of not less than 3 feet in all directions from the edge of the roof. So when we're saying that, Jay, what we're really saying is on a typical roof, not using your exception, and we'll talk about what you do.
Sure.
But typically above a roof, I have to make sure that those service conductors stay 8 feet above my roof. Now we have some allowances here depending on the pitch and things like that, which we won't go into too much detail tonight. But since you talked about through the roof penetration, I wanted to point out to the viewers that typically we're going to be 8 foot above the roof. Okay, so that if somebody's working on the roof, they can't come in contact with it. Okay, that's a safety deal. There's no protection on those conductors most of the time, right? We're in 230, so we're talking service. No protection, so you don't want to come in contact with it. However, it would be very difficult, and when we say 8 foot, we mean 8 foot up, and then that 3 foot is in all directions, so that's basically like taking an umbrella and sticking it over the roof. 8 feet up, and it overlaps at 3 feet all around. Okay, so so that would be very hard for Jay's application for be able to come from a service drop and then make a connection to a through the roof penetration, which is just at the eave of the house. All right, that would be tough for him to make that penetration because this clearance is out 3 feet and up 8 feet. So what Jay is utilizing is exception number 3. And Jay's exception is, it says where the voltage between conductors does not exceed 300, and again, 122.40 is not going to exceed 300. Between conductors, it's 240. So we're good there, right? It says a reduction of clearance above only the overhang portion of the roof to not less than 18 inches shall be permitted if, number 1, not more than 6 feet of overhead service conductor, so that's the point that comes across from the drop, that comes across that overhang. The amount of portion where it starts to cross the overhang to where it terminates onto Jay's rise, that's not more than 6 feet of conductor. Okay, so, shouldn't be because you're just at the overhang, so it shouldn't be a big deal. But okay, 6 feet. And then it says 4 feet horizontally past the roof overhang. And 2, and that's talking about the 4 foot. So it's 6 foot of overhead service conductor, and it is 4 foot horizontally past the roof. Okay, so as it comes from the edge of the roof in 4 feet. So he can't have more than 6 feet, and he has to do all this within 4 feet of the overhang. Okay, which he's probably going to do it anyway, right?
Yes.
So shall be permitted 1, not more than 6 feet of conductor. And it says 4 feet horizontally pass above the roof overhang. And number 2, they are terminated at the through the roof raceway or approved support, which is what Jay's doing the moment that it comes up. Okay. So you have from the edge, if you could see me in the picture, you have the edge of the roof. You got 4 feet in. And the point where it comes down, the amount of conductor that goes over that can't be more than 6 feet. And when it penetrates through, it has to make connection to Jay's riser that's coming up with his weatherhead and the supporting component on. So that typically gets done, Jay, doesn't it? Usually, be honest with you, probably the 4 foot's not even a real issue. That usually gets done within the first 2 or 3 feet maximum. Yeah,
because we're mounting that panel on the back of the house. In most applications, and that roof hang only hangs over a few feet, so that's not an issue. The 4 feet going back, I think, when panels were inside maybe sunrooms, and they built off to them, built out, extended them over. That could be an issue. But then again,
because you can't have more than 6 foot of conductor, and it can't exceed more than 4 feet over the overhang. So that definitely could be one of those problems.
But again,
go ahead.
you're doing these older homes like we're doing, some of these main panels are even in kitchens, where you'll have a meter on the outside, whether it's underground or overhead, and most of the time it's overhead, and then it'll penetrate through the house, maybe even 10 to 15 feet of unprotected wire.
Total violation of 230.70A1. But obviously it's been done for decades, and you got to cringe because you've got unprotected conductor. The only protection that conductor has is when it terminates into the panel. It does have what's called overload protection because it's inherent by the breaker, but it has no short circuit or ground fault protection, and it's just being run throughout the building. I remember I lived in a house back in Charlottesville, Virginia. Our meter was actually in the bathroom.
Oh, my goodness.
And it came in, and this is an old house. I mean, this has been a long time ago, and I think it was, might even been knob and tube. It literally came in, and just wires come out of the ceiling into the meter. Meter was mounted in the bathroom, only about 3 feet from the shower. Came in, and it hit the top line side of a meter, old glass style meter, and then it came out of the low side, and it came over, and it hit knife switches. And then it hit small Edison based fuses. So, but that was right there. If I wanted to be slick, I could have jumped that meter and got me some free power. But when they noticed that my meter wasn't spinning, I'd be in jail. So at the end of the day, where did those conductors come from when they came in? Them things probably ran halfway through the attic, and they're unprotected and old as Moses. So scary.
It is scary.
So when you do a service change, I don't know if we even go there yet, but if you do a service change and now you've got these conductors running halfway through, many jurisdictions are going to say, now that you're doing a service change, you've got to fix that condition. You've got to change it.
And for us, if it's in a kitchen location, a lot of times we just we either turn that into a remote distribution panel. That way we don't have to extend the circuits more than 6 feet and turn these circuits into arc fault protection, because a lot of them, like Paul, they're multi-branch circuits. So it's the A and the B phase circuits that are sharing a grounded conductor. So they're sharing the neutral. And
that
when you get
can make it difficult
on the 2020, and especially with the 2020 arc faults. I've been able to get 2-pole arc faults, and GE makes it to where you use 2 single ones and you put a breaker tie and you connect the multi-circuit neutral to one of the full-size breakers, and then you breaker tie them together and you take the 2 pigtails off the breaker into the neutral bar. But when it comes to dual functions, they don't correspond. They don't make a 2-pole dual function. So that's where you have to really be careful on where you're using multi-branch circuits, and you're trying to repurpose these existing circuits throughout the house, especially for a disposal and a dishwasher. So again, you have to know what you're doing. You have to know what code is, and then you also have to know your product that you're doing. But for the kitchen panels, we normally turn them into a remote distribution panel, or we'll turn them into a J box, and feed circuits to them. But if it's the old 2-wire, we'll just abandon them and tell the contractor, listen, we need to rewire this whole house, or we're not touching it. So
there you go. Jay can be selective like that.
Can. For sure.
Before we move back off and kind of finish and get inside of the building a little bit, I want to make sure that I also touched on my example. Whereas, let's say I ran my cable up the side and next to the eave, but I didn't penetrate, like Jay using the allowance in 230.24A, the exception number 3 to do that. Well, remember what we said, that 8 foot and that extends out 3 feet? Wouldn't it make it kind of hard to bring service drops as well to my connection on the side of my eave, because that 3 feet extends out and up? So we do have an allowance in another exception, and that is exception number 4, that says the requirements for maintaining a vertical clearance of 3 feet from the edge of the roof shall not apply to the final span where the service drop ends, or overhead service conductors are attached to the side of the building. So where I'm going to drop down, I get to ignore that 3-foot issue, the point where it starts coming down to the side of the building, so that I can make that connection at the eave and things like that. So again, your general rule, 8 foot, measured 8 foot up, 3 foot out, up. But if something's coming into that zone to come to the side of the building and it's going to penetrate that 3-foot envelope, then you could argue that, if you're penetrating that 3-foot envelope, it's got to be 8 foot high. But then how in the world does it ever connect to the building? It's got to get to the building. So this is an allowance that lets you be able to go and be less than 8 foot and penetrate that 3-foot perimeter and get to the connection. So that's the exception number 4. So we wanted just to make sure that we kind of looked at that a little bit, so we got it. So we're good with that. All right, Jay. So we kind of got that. We made the connections. There is also clearances that we have to be aware of. We're not going to get overly cozy, but we talked about it. So you've got drip loops. So you're going to create drip loops. I'm going to create drip loops in all of mine. Typically, the drip loop's going to be below the service head. And if it is a SE cable, which could also be a gooseneck where you seal the end of it, wherever the SE cable terminates or the end of the SE cable sheathing itself, you seal it, and your drip loops need to be below that as well. And in your case, the drip loops have to be at least 18 inches above the surface, right, for that exception, because it says that overhang the roof the conductor's not less than 18 inches. So you have to have some separation. You can't let them come down and touch the roof. So you got a lot of things when you're penetrating. You've got to have the point of attachment. You have to have the guy or the supporting, the rigid, for your case, adequate support. You have the drip loops that have to maintain clearance because those conductors can't be closer than 18 inches from the surface. You have to worry about the 4-foot in. You have to worry about that its conductors are not more than 6 feet. I'm an underground guy, man. I'm just going from a transformer underground up into a meter. I'm done. I like underground applications. It seems this is way more complicated. But at least we looked at all of the options here to be able to do that.
Yeah, going overhead is a little tricky. In most jurisdictions, though, they know their code and we know our code, so we tend to get along on them. And when you're doing a service upgrade on one of those older homes that might be from the 70s, 60s, whatever, there's nothing that you can do that will downgrade that install that's already there, pretty much. So you're
only
better not.
What do most of them say? Most of them will say, look, you're making it better than it was.
Yeah.
Right? You're making it better than it was before. What I did want to talk about the drip loops.
Yeah.
Right here. 23054F. Drip loops shall be formed on individual conductors. That's forming them, having them drop down before they go up into the service head to prevent moisture from entering. I'm sure Jay does all that.
Yep.
It says it has to be, again, below the level of the service head or below the level of the termination of the service entrance cable sheathing. So whenever the sheathing stops and the conductors come out and you're going to heat shrink the end, that is the end. So if it's a gooseneck, then it hangs over. That's where the end is, and that's where it seals. And you need to just stay below that, okay? Do your little drip loop. Trust me, you don't want moisture getting up and into it. And Jay, you were saying something about at one time, the weather heads and when the conductors go into the end of the weatherhead, and we're talking a plastic, it might have been Bakelite years ago. Now it's probably a thermoset plastic. You were saying you got to be careful because people start poking those things. Then you kind of defeat the purpose of the reason it's there, isn't it?
Yeah. So when you're doing a overhead riser, we typically go up about 2 foot minimum to allow that 18-inch drip loop to kind of end the topic on drip loops for us is you got to go up 2 feet. You got to find that happy medium between 2 feet and 3 feet if you can use those allowances. And then when you put that service head, or what we call it in the field a weatherhead, normally it's a 2-inch because again we're using a 2-inch piece of rigid metal conduit going up. You have that weatherhead and it has these kind of
knockouts or little
knockouts.
Yeah.
That you can use that you can use, and some of them are smaller. So if you're using a smaller conductor, maybe for 100 amp service or 150, you can use a smaller. Once again, we usually typically give them the option to go to a 200 amp service, and we'll run 4-aught aluminums up there from the meter up. So we'll knock out those 3 holes. And if you don't train your 4-aught, even though it's aluminum, it's a little lighter, easier to bend than copper is. If you don't properly train those wires and you throw them in that plastic part of that service head, and you're just rushing and you're throwing the top on and you're trying to get done with it so you can get power back on, you can actually end up taking the UL listing out of that and allowing moisture and water to get into that weatherhead if you're not careful enough, because that wire will break that plastic. So instead of 3 separate individual holes, you create one huge hole that will even allow, it defeats the perfect, the defeats the purpose of what it's entitled to. So know what you're doing, be careful with them, train them properly.
Okay. So we did that. We made our connection. We have our heights. We done all that. We've run our cables down. In your case, you run your rigid down. You go to the meter.
Going to the meter.
So you're at the meter.
Yes.
We would install the meter for the utility company. I'm sure y'all would install the meter.
Yes,
we call
do.
them. They give them to them for free. We remind people all the time, meters are not service equipment. It's simply a way to pay the utility. Conductors are just passing through it. When you go in the line side of the meter and come out the load side of the meter, the number of conductors going in and going out doesn't change. Okay, it's just passing through. Typically, the meter on a residential, the grounded neutral conductor is what bonds the meter. 250-142 permits that, so we're using the grounded conductor. That's usually inherent in the meter assembly, right? And so then it comes out of the meter and it goes into the service equipment, whether it's exterior mounted or if it's interior mounted. However, I know Jay wants to talk about this here. So what's recently changed, and I'll let him kind of talk about what's recently changed. Y'all have watched my videos on some of the 2020 changes, is the requirement for the emergency disconnect for 1 and 2 family dwellings, that type of applications. You've got to have an emergency disconnect. And it could be your service equipment, or it could be a disconnection switch that serves as emergency disconnect. Okay, doesn't necessarily mean it's service equipment. But there's a lot of labeling you got to do. And we'll look at the code, but I will let Jay talk a little bit about it because he wanted to talk about it. And this is something that I think is interesting, that when I remember this passed, requiring this for the 2020, a lot of people got bent out of shape. But in the West Coast, they do this all the time. They put outside service disconnect, all that. This isn't new for them. In Virginia, where I'm at, never. We go from the meter straight into the panel, and that's where our main breaker is. So, Jay, tell us a little bit, and we'll look at the code a little bit, because this is a change that you want to be aware of. It's going to be significant cost to you. At least a couple $100 to do it, at least.
Yeah,
but,
of course.
And I'll tell you why we did it. But, Jay, go on and talk about it a little bit.
Yeah, so for our meters, our jurisdiction, our power company requires us to do a bypass meter, which is a lever on the right side of the meter itself, which will open or close those jaws. It's a safety feature that the power company requires us to have. I don't know if that's
disconnect. It's not a disconnect though.
No, it's not
just
a
bypass. Yep.
It's a bypass. And again, this isn't in all areas. I don't even think this is pertaining to the code, but this is just a local jurisdiction POCO requirement. So then when you go from the meter, a lot of times we do all-in-ones, which means the meter is attached to the actual main service itself too. And
it's
so you
combo.
bring your, it's a combo. Exactly. It's a combo. So you literally take out one meter, and normally the older style panels that we replaced, the meter is very tiny. I mean, it's super small, maybe sometimes 12 by 12.
So the round ones,
meter.
The round meters, the old round ones are basically 60 amps. The 12 by 12 inch square ones, they were 100 amps.
Sure.
And the rectangle size was where you started to see 200 amps. Okay. And then the huge rectangle ones was where you would see a 400, 320.
Sure.
Okay. But those small round ones were 60. And then again, some people use the round ones for water heaters, and they were 30. So again,
you cringe when you look at these meters.
There's no
and
room
you
in
can
there. No
no,
bending space in there.
and again, you have this meter that either 60 or 100 amps, and then it feeds maybe a split bus older FPE panel that has multiple circuits on it. And again, you're looking at the service because you're doing a service upgrade. You want to bring this panel up to code, and you're cringing at the old install. But at the end of the day, you take those off, you put on your new meter. Either you do a combo or a side by side where you install the meter and the riser, and then maybe you do like a foot or a foot and a half piece of conduit between the meter itself to the panel. Normally, I use plastic. That way, I don't have to bond it. I just
Plastic keeps it simple.
keep it simple.
Keep it
Keep it
simple.
simple, and you can get these parts from Home Depot. I mean, they sell them to where any electrician on a Sunday, let's say the supply houses are closed, you just go down to Home Depot. Again, Home Depot specializes in my area, Square D, and I'm an Eaton guy myself, so I normally use Eaton. But again, Home Depot's there. Long story short is I ended up installing.
All those brand name dropped in there. I'm surprised you didn't say nothing about Milwaukee, just to throw it in there.
They don't make equipment. They don't make the equipment for us. But I am using Milwaukee tools to install their equipment. So there we go. Here's my Milwaukee shout out. But I ended up installing on a weekend. No, it was during a weekday. But Home Depot opens up at 6. My supply house opens up at 7. And my guys show up at 7. So I needed to get a bypass meter. I ended up installing a non-bypass meter. Go figure. Or, no, I'm sorry. Back up. I had the service drop set up on the house. And again, I'm switching gears on you guys. But I had the meter and the panel next to the meter on the house itself, and the riser went up the house. It didn't go through the eave. It went
just
up
went up to
building,
the side.
Just up the side. And I had my weather head facing west towards the utility line. Well, 10 feet over was a detached garage where I was going to feed underground. Utility turned us down. They said, no, you cannot pass over the garage to the house point of attachment. You now have to put the point of attachment on the garage side since it's closer to the transformer. And then we went underground to the house. So really our house panel was a remote distribution panel. So I was scrambling. I was like, okay, whatever. So I take this meter down. I end up
if the drop came to the garage and it never penetrated the garage and it stayed outside and then ran down and over and under again, then it's still service conductors. If you didn't have a disconnect, if you didn't have a service disconnect, then on any of the supply to that, then you would not have had. It would not be a remote distribution.
I had a service disconnect. I had a on the garage. I had to put in. I put a 816 all-in-one. So I fed my detached garage circuits, and then I did a feed-through lug system.
Oh, and then went on and got the house.
And then I went underground to the house. But the house already had my neutrals and my grounds tied together because, again, that was going to be my main service. So anyways, I'm rushing, and I go to Home Depot, and I see this sweet deal on this 816 all-in-one. I'm like, all right, cool, I got it. Boom, boom, boom. I bring it to the garage. I install it. We install the riser, connect it, do the underground URD, poke up. Again, so now I'm going from the main service on the garage with a 2-inch piece of conduit that sleeves down. I have to use a slip sleeve or a compression coupling because of the way that the houses settle and the conduit going down. Even if it's just a sleeve to your 2 foot down. Well, I did 2 foot. I'm not sure what 300.5 requires. I'm pretty sure it's somewhere in there, but we would go down. I think it's 18 inches, but we would go down a little bit further, right? Because it's the top of the URD that needs to be 18. So we'd go down 20 inches. Well, this slip sleeve we have to put on. It's a compression fitting that leaves an open area that maybe is about a foot tall. That if the house ends up settling down,
it's an expansion fitting.
Yes, it's an expansion fitting, so it doesn't crush anything or cause issues on the installation. So I did all that. I have everything installed properly. Utility comes out. They look at the all-in-one meter that I bought from Home Depot, which was a Square D, and it didn't have a bypass meter, and I failed. So now I have to scramble again to take off something I just installed. I threw it in the trash because here in my local jurisdiction, we can't use that, and why Home Depot would sell it.
Man,
Drives me
eBay.
nuts.
Come on, man. Sell it on eBay. People
Oh,
buying
man,
used equipment all the time, man.
I was so frustrated with that thing, Paul, man. I just threw it out, man. I didn't piece it out. I didn't care. I threw it away. I was frustrated. I was mad. I went down to my down to my supply house, picked up a new one, installed it.
I am surprised that the Home Depot would sell, knowing if that is predominant in that area, that all meters have to have a bypass, which is interesting, because we never had any bypass on anything of ours, especially residential. Never would have had a bypass. Wow. So, and which just brings us into this point with 230.85 emergency disconnect. You have three options here. Okay.
Oh, sure.
So it's a one and two family dwellings units. It says all service conductors shall terminate in disconnecting means having a short circuit current rating, that's an SCCR rating, equal to or greater than the available fault current, which is hopefully going to be supplied by the utility up to the point of termination, installed in a readily accessible outdoor location. Outdoor. It's got to be outdoor. That's new for us in Virginia and many places around the country. In some places in California, they're like, what's the big deal? We do it all the time. Yeah. Okay, Arizona, typical for that type of thing. So anyway, has to be outdoor. And it says, if more than one disconnect is provided, they shall be grouped. Each disconnect shall be one of the following. Okay, three options. The first one is pretty simple. Service disconnect marked as follows: emergency disconnect and its service. So if I put a panel outside, so let's say Jay wants to put an exterior panel, like his meter combo. He puts it outside. That's a service disconnect, because everything on the load side of it's going to be feeders and things like that. That's a service disconnect. He's going to have it marked service disconnect, and that's what he probably had before. The little blue labels that probably came already with the equipment said service disconnect. However, now, if that is the case, because of this rule outside, it's got to also be emergency disconnect. And it will service both. It can. It's fine. But you got to label it. So this is a labeling requirement. And, Jay, we were talking about it before with the show, is who's going to provide that label? Well, it's in the code, so you're going to provide it. And you're going to make sure that it complies with 110.21b, as it states at the very bottom. So it's got to endure the location. It's got to endure weather. It's got to be designed to be, obviously it's outside, so it has to be able to survive, right?
Yep.
So that's the option. I mean, that's probably what people are going to do, Jay. They're probably going to put a panel outside. It's got service disconnect, and there you go. Well, what if you come to me and Jay says, I don't want to do that. I want to put my panel inside the building. I want my meter outside. Well, then I have an option number two. I can put on what's called a meter disconnect. And if I put the meter disconnect in, remember, it is not service equipment. It's a disconnect. And it probably is simply going to be a disconnect. It's not going to have any overload protection. Just going to be a rated meter disconnect. And it's going to be there, and it's to disconnect the power. And it's got to be marked emergency disconnect. It's got to literally say meter disconnect. That's what it's there for. And it's got to make it real clear that this is not service equipment. So what that means for people that do know, that are in the know, that means that is not considered service equipment. You don't create a 4 conductors downstream from a meter disconnect where you separate your grounded and grounding. Okay? It is just a disconnect. It is not service. It's also not going to have it's not going to have a main bonding jumper in there, because it's not a service. It is just a meter disconnect. And that is your option. Now, where do we see meter disconnects most of the time? This is why this one was intriguing to me, because most of the time we see meter disconnects on commercial buildings. And the reason they do that is because if they want to pull the meter, they want to be able to pull it and make sure that they kill power to the building. so that when you pull the power, you don't have any contribution from any motors or anything that could be running that is being they're motors. But once you pull the power, then they start to wind down, they'll backfeed, they become generators. And you could create a large amount of available fault current. So they want it for commercial applications. They like to have these meter disconnects. I did not really see them that much for 1 and 2 family dwellings. Okay. And I'm probably still not going to see them. Okay.
Yeah.
So, so that application. And then of course, the third option is other listed disconnecting switches or circuit breakers on the supply side of each service disconnect that are suitable for use as service equipment. So they still have to be rated as suitable use as service equipment. So they got to meet that rating, but they're also not service equipment. So this could be a listed fuse. This could be listed circuit breakers. As long as, again, it's a listed disconnect switch, it can be on the supply side of the service disconnect. It still has to be rated as service equipment for use as service equipment. All right. But it's not service equipment. Okay. The service equipment is still the panel inside. So I could put this disconnect outside, and that's going to be your normal disconnect. This is going to be a normal 200 amp disconnect outside.
Right. Okay? Just one handle for the fire department to come in.
Yep.
There's an issue with the building. They come in, they see a meter, they see that handle. That handle's now, or that equipment is now labeled with that emergency disconnect, not service equipment. But they don't really care whether it's service disconnect or not service equipment. As far as the fire department, they're more triggered with the red, because what Paul's saying and what I did is I just recently I passed the inspection. So we're in Colorado. We're in the 2020 code now in most jurisdictions since August 1st. So pretty much if I pull a permit, which I did.
Hold on. Colorado. Hold on. Not like that everywhere.
We don't only just get high in Colorado. We actually succeed and pursue with what's up and coming. So if you want to come to Colorado and join us. Anyway, so I had an inspection, which we've been ready for it, Paul, and we do a lot of basements. I've told you guys we do basements.
Yep.
So we've been putting dual function breakers. I know we're not talking about that code, but we've been trying to be the forefront of the 2020 code as far as electrical contractors. So anyways, we do this.
And for those real quick, you have to remember podcasters. So dual function is an AFCI and a GFCI device. Okay. That is called dual function. Okay. So not a combination. Combination AFCI is looking for parallel and series arcs. He's talking about dual functions, so there's a difference. Dual function does GFCI and AFCIs, okay? And of course, Jay is also referring to the fact that basements, that code changed in 210.8 as well now and requires GFCI protection in basements, whether or not it's unfinished or finished, okay?
Yes.
Don't know why it should matter, because if it's finished off, I would think it's sealed basement, whatever. But anyway, code is what it is. So that's what he's talking about there. Dual function, picking up two concepts here: AFCI and GFCI in one device. Okay, pick it back up.
Yeah. So we've been installing the dual function breakers for the receptacle circuits in the basements, and that could be a hallway, a general purpose living room. It could be a bedroom, anywhere that the code states that it needs, in any receptacle needs to be GFCI. So there's its plus and minuses. I'm not going to get into those because we'll hit that probably on another episode. But sure. What happened was I had an inspector come out and he looked at our panel, our main service, because we upgraded it to a 200 amp. And he had passed us because there's nothing wrong with the wiring. There's nothing wrong with the grounding electrode. There's nothing wrong with the ground rods and the number 6 bare copper going from both ground rods up through the intersysting bonding jumper to the ground bus bar where everything bonds. Everything was good, but he went back and referred to 230.85 which is what Paul's touching, and it says the emergency disconnect. And for our application here, it was 230.85.1. And he said, okay, you need to have this labeling. And if you go to 110.21, which is what it refers to on the bottom, it says B. Well, if you go to B2, the label shall be permanently affixed to the equipment or wiring method and shall not be handwritten. So I can't just go and write this in red Sharpie. You have to get a professionally done pretty much label. And what I found that I'm going to tell you guys.
Remember, this doesn't have to be red.
Oh, sure.
Because that's only applies to things like the red has to do with whether or not it's considered dangerous, hazardous, caution. Right. This is just a marking requirement. But
I'm going to go above and beyond.
Everything else. You're going above and beyond.
I'm going to go above and beyond. And what I did was I called up my local company who makes my T-shirts. Shout out to Lab 7 in Colorado. And I had them make 100 stickers for me. And how I had my stickers labeled was it's a red background with white lettering. And they say what exactly what 230.85.1 says: emergency disconnect, service disconnect. And so I'll have those printed off because, again, we do a lot of outdoor installations where the main service disconnect is outside. So, yep, right there, 230.85. And I actually went ahead and had above the emergency disconnect and service disconnect, I put in there, I had them put in NEC-230.85.1. So that way it gave the inspectors a code reference as well. All of us old guys
are hoping you're not using dashes. It should be 230 dot. But, back in the day, it used to be dashes. So maybe you're having a flashback or my oldness is wearing off on you.
No. I said NEC dash, and then I said 230.85.
That was me.
Oh.
That was me.
Sorry.
That was on me. I was just teasing.
So we just went ahead and put it in a red background with white lettering, just to make it for the purpose of the fire department looking for that red emergency disconnect.
Okay.
And then we got hit with 230.67. I don't know if you can pull that one up real quick.
You can.
I believe it is too. Let me get in my code book too.
So 67. Well, that's SPDs.
Yes, and because it was 2020 code, if you go 230.67D, which says replacement, where service equipment is replaced, and that's what we did. We took out the old one and we replaced it with a new service.
Absolutely. Some of the people that have listened to my code change where I discussed this topic realizes that you're absolutely right. And a replacement, the code is very few times does the NEC do this. But this is one in the 2020, which is going to require you to put a SPD, surge protective device, on the system. So he hit you with that too, huh?
So he hit me with that. Again, these are things that I can do on the final that he'll come back since the basement needs to be have a final inspection. He'll come back and look at the meter. But again, if I was to just do a service upgrade without the basement and I didn't have the surge protection device in there, 230.67D, or for, all locations, somewhere in there it says just for period, right? All service supplying dwelling units shall be provided with. So 67A is more for new installs. D is for replacement. So either way, if you're touching that panel and you're upgrading it, or you're doing a new construction home and you're installing a new panel, you're putting in these surge protectors. And to me, that means more cost on my end as electrical contractor.
It's going to.
It's safety for the home, but what?
But SPDs do work in a sense that, again, we have so many sensitive electronic equipment. The whole concept behind the push this was because of sensitive electronic equipment. Smoke alarms are sensitive alarm systems. We have a lot of high-end appliances, although that's not a safety issue. But we also have AFCIs that have electronics inside of it. And surges and spikes and things like that can cause problems and keep them from reliably working. So this is a good move. I don't have any problem with this. I will say this is a great opportunity for electricians around the country to market themselves to, even if it isn't a service upgrade. If you're in an area like Texas and you get lightning storms all the time, or you're in Jay's background where you're getting lightning right now, you see all that lightning back, then you want to be able to go to somebody and say, hey, we'll put it in an SPD for you and so many odd dollars, and you're really enhancing their system. You never know.
Make sure you have room for that SPD if you're putting it in an existing panel, an existing main service.
Yeah, so we have exterior ones, and we have some that can go in. Some panels like Eaton, they like to do a big thing where they take a panel and they'll design it so that it can be installed in the panel.
I have those.
Some of the manufacturers now make them that actually are the breakers itself, and they literally go in the panel right on the actual bus. So again, there's a bunch of different varieties, but yes, definitely make sure. And again, you keep those leads as short as possible. Okay. Surges don't like to make loops. Keep it short as possible in that panel from the point where you make the connection to the breaker to the actual device. Keep it as short, unless it's the kind that stab on the bus, then you don't have to worry about it. Right?
Yeah, you don't have to worry about nothing. And that's what Eaton does. They make that stab on one, but again, it's 2 full breaker sizes. So when you're doing these panel change outs and for you newer guys, and you go to Home Depot, you go to your supply house, and you're looking for the cheapest, most cost efficient panel size, make sure you know what you're doing, because you're taking all these spaces up with these new requirements, that you're going to get this combination panel that might be a 2040, and you may be actually required to install 30 full size breakers in there now. Again, if you're moving the panel more than 6 feet, the arc fault requirement comes into, but we're just talking about just taking a panel out and putting one back in. Make sure you're putting in the surge protectors and make sure you're labeling them properly. So
while we're going to touch on that, because I want to make sure we wrap up a couple of final things.
Yep.
When you're doing a service and you're doing an upgrade and you're doing a new service, obviously you got to establish a grounding electrode system. If you're using ground rods, it doesn't have to be larger than a 6 copper. If it is water pipe ground, like you traditionally see in Colorado, then you got to use the table 250.66. And that's going to, based on the size of the service conductors, that's going to be what determines the size of your grounding electrode conductor to your electrode. Water pipes, you have to supplement it. So you have an option to supplement it. You can use a ground ring. You can use a pipe, plate, or rod. You have other options to use. You just can't supplement a water pipe with a water pipe. So if you're doing a service change, you might come in and there might not even be a grounding electrode system on that building when you get there.
Yeah.
And if you're doing a service change, most of the jurisdictions are going to say, hey, you're going to have to establish one now. Yep. And you obviously wouldn't use a UFER because you don't know what's in the footing to even use it. You don't know what's there, so they won't let you do that. So you're going to have to drive, probably the easiest thing is drive ground rods, right?
Yeah, that would be the easiest thing for us. A lot of times they have that water pipe coming in from the utility, and it's usually copper. So what happens
So within the 5 point of entry, you make connection onto that water pipe ground with your grounding electrode conductor.
You have to. And if there's a, gosh darn it.
And you have to supplement it. You have to supplement with another type of electrode other than another water pipe. That would be kind of pointless to supplement a water pipe with a water pipe. Makes sense, right? So you got to have another one. And for those that don't know about grounding and bonding, I will encourage you to go get our training program, Grounding and Bonding. It's a great program. Jay hadn't started it yet, but he has access to it to join it. And it really teaches you a lot about grounding and bonding. So check that out if you're interested over at Master the NEC, or the Electricians Academy also has a course on that as well for grounding and bonding. Okay. Little bit of toot, toot. All right. So I'm trying to cover a lot of things here, Jay. So we do the grounding electrode system. If it's not there, you have to establish it on the service change. You can't just say, ooh, it wasn't there, I get to leave it. No, we need to establish that. Now, you were talking about the panel. Now, another thing, when it comes to AFCI devices, a lot of people ask me questions around the country. If I'm doing a service change, does that immediately kick in the requirement for me to upgrade to AFCIs? Remember, the AFCI requirement is a 210.12 rule. That has to do with the branch circuit. Okay. If I'm extending it or modifying it, then I would have to bring it up, except we have an allowance in there that says, as long as I'm not extending it more than 6 feet, then I don't have to bring it up. In other words, that's like saying I'm not really extending the branch circuit. So in Jay's case earlier, he's taking a panel in a kitchen or moving it around or moving it somewhere. As long as he doesn't go more than 6 feet, even though he might have that old panel being used as a splice point to reach a new one, as long as it's not more than 6 feet, then it doesn't kick in the AFCI. And I think a lot of people get confused on that. They think a service change, that you have to upgrade to AFCIs, that you have to change those things. No, that's not. As long as you're not messing with the existing branch circuit, it's not required to do that. Now, again, I know jurisdictions might try to force that down your throat, but if you really don't want to do it, you could push back. You could go above your inspector's head. You could go to the building official, or you might say, look, I don't want to wrestle with a pig in mud. I'll just do what they tell me. But the AFCIs aren't cheap.
Not with those, man. I'm not doing what they tell me. That if I'm taking out an old panel, because again, we talked about the multi-branch circuits, which a lot of these older homes use those. I'm not playing that game with them, because that normal breaker, that regular 15 breaker, will not trip as quick as a 2-pole arc fault will, because you don't know where these neutrals are attached to, and that's not your job to inspect them from the breaker out, unless
I'm not going to rewire the whole house. I didn't get paid to rewire the whole house. I'm just paid to do the service change.
Let me do the service change, make a couple bucks, and get out of there. But you want to do it right, like Paul's saying. You want to hit the grounding and bonding. You want to use the proper service entrance conductors. You want to put in the proper equipment like the SPDs, and you want to label it properly. Another thing that I run into a lot too is the heights of the panel. So if I'm taking out an existing service, and in the back of that service is a 2-inch conduit that's feeding all the branch circuits out to the house, and that conduit,
which incidentally is a code violation, by the way. You can't run a single conduit, and there's an allowances for a surface mounted panel where it goes up, and as long as it doesn't penetrate a floor, as long as it's not more than 10 feet and not less than, I can't remember, probably could go look at it. It is 312.5C in that application. But again, and you seal the ends and do everything, then I think it's 18 inches and not more than 10 feet, and you seal it, then that's an application where you could run, for example, branch circuits like NMB inside of one. But I see this all the time. They come out of the back of a panel, and they bring all through a connector, sometimes they'll put a 2-inch PVC connector in there.
Like CA.
Yeah, and they'll run everything through it. That's technically a violation of the code, because the code requires you to secure each non-metallic sheath cable to the actual enclosure, and you're not doing that. And so there is an allowance for that in 312.5C, but that ain't it. Coming out the back of it is not it. Now, I know it gets done, and I've got pictures of it, and I've seen people do it, but it's technically, and jurisdictions allow it, but theoretically that's not code compliant. Anyway, I'm sorry. I bogarted your statement.
No, you're fine, because a lot of times when you're replacing it, you're not going to bring these ones singly in. They're kind of grandfathered in, just like the circuits. You're not going to put in arc faults, kind of like what Paul was saying, or dual functions that have the arc fault GFCI protection at the breaker. You're going to use a normal breaker. So when you use that conduit or that TA and it comes into the back, and depending on where your panel lays out and your meter lays out, you may be penetrating straight across from your meter into your main service panel above the bus bar. It might not be a knockout that's down low. You may have to create your own knockout on the side and penetrate into that, which if I do that, then I use a sealed weatherproof lock ring on the outside. So if I'm taking a piece of 2-inch PVC across from meter. The meter knockouts are perfectly fine because I'm using the bottom of the meter, let's just say. So I have the meter. I'm coming at the bottom of the meter at maybe 4.5 feet.
Which is below live parts. Okay, it's not above live parts.
On
So
the meter
that's
side,
what he's
I'll be
talking
below.
about in the meter. That's why he's coming out from the bottom side of it. Okay.
But I might have to place my panel because of the conduits that are existing. I might have to run that piece of conduit over to my main service that hits the center of that 3-foot box. So I may be coming 1.5 feet at that midpoint where I am above live parts.
Mm-hmm.
And if that's the case, then I always put a
well, you'll seal
sealed lock ring.
You'll seal it so that you can keep from water intrusion into it.
Exactly.
Probably not something that our podcasters can visualize that, but again, it's an example of you get dealt lemons and you make lemonade. And in his case, he's doing a old to new, and you've got to work something out. Now, what I did want to show you, Jay, is this is 312.5C.
Okay.
And this is where it talks right here. It says where a cable is used, each cable shall be secured to the cabinet, cutout box, or meter socket enclosure. Of course, the cabinet is what your panel board is in. So you're connecting to the cabinet, and that is your panel, your cabinet. So the exception to doing that, because if you ran them all in through one knockout, then you wouldn't be securing the cables to the actual cabinet. But the exception allows me, and if I can meet all these rules here, then it allows me to do it. It says cables with entirely non-metallic sheathing, so it's very limited non-metallic sheathing, shall be permitted to enter the top of a surface-mounted enclosure through one or more non-flexible raceways, not less than 18 inches, I was right, and not more than 10 feet in length, provided all of the following conditions are met. I've got a bunch of conditions that are going to have to be met here, none of which allows me to come into the back of a panel through a single connector or fitting, okay? You have to meet you'd have to meet every one of these rules in here to do that. Okay, so, but have I seen people allow it? Yep. But that's typically, each one needs to be secured to the actual enclosure. Now, this also, as people ask me from time to time, it says, well, what if I'm taking an NMB into a cabinet through a raceway? Because you could do that, right? And then they say, how in the world would I ever secure that to the cabinet? And my answer to that is you don't have to. The raceway is the wiring method that's secured to the cabinet. You're running the actual NM through it. It doesn't have to. The reason that we're securing cables to cabinets, Jay, with connectors is because of abrasion. Okay, movement, enter into it, abrasion. If it's coming in through a raceway, there's nothing to abrade.
Sure.
It's just coming into the actual the cabinet itself. So again, you don't have the requirement to secure it. Most people think you can't run NMB and things like that in raceways anyway, but you most absolutely can. You just got to be careful of raceway fill requirements. If you're using a small piece to protect something from physical damage, then you don't have a raceway fill requirement. It's just, it's just there for physical damage, and then it opens up on each end, and then your NMB goes on its way. Okay, so all those rules are there. Also reminds you to go look in the back of the code. That would be Chapter 9, Table 1, and all those notes are going to explain physical damage and when it's a complete run and all that stuff. Totally off topic for today. But I just wanted to wrap it back around to, what Jay is saying. You run into some weird installations, and you have to do things like water could come in, so he's using a seal, lock nut with a seal on it or something in order to keep moisture from coming in to maintain, because it above live parts, things like that you have to do. You're running into a bunch of stuff on a service change, okay? It's not always just easy, right? Boom, boom, boom. Sure. So that's what we do. We also have to be careful of what, Jay? We also have to be careful of working clearances.
Yeah, you do.
So a lot of people say, well, look, if I had a 100 amp panel and I'm upgrading it to 200 amps and I didn't have the working clearance, do you mean that I can come take my 100 and then I'll go up to 200 and I still don't have working clearance? You're going to have to talk to your jurisdiction on that one. Okay, because there are many jurisdictions in the country that might say that's not a like for like. In Virginia, we had a rule called like for like. Yep. If you were taking a fuses and changing it out for 100 amp circuit breakers, it's a like for like. If you were taking 100 amp fuses and now you're putting in a 200 amp circuit breaker, that's not a like for like. Okay, that's an increased capacity. So they might say, now I need working clearance. And if you ain't got it, you might be screwed. That might be the difference between now that panel cannot be this, now you might have to alter something. And that's the last thing you want to be pricing it and go do this job and then turn around and have some inspector tell you, no, you don't have the working clearance. And you didn't even think about that when you went and looked at it. So those are good questions to ask. And don't be scared to ask an inspector and put them on the spot. Even before, I don't know about if you've done this, Jay, but have you ever done anything where you said, let me call and see what they're okay with before I do something? Let me just check with them before I go and get invested in this.
Yeah, I've had courtesy calls too. I know most inspectors in the jurisdictions that I'm working in, because I've done quite a bit of work in every jurisdiction around the Denver metro area. So I'll call down there, whether it's the chief inspector, whether it's just talking to whoever answers the phone, and I say, hey, I have an inspection today for this rough. Let the guy know who's coming out. It's not to do a complete rough. It's more to make sure that I'm doing this installation per your requirements, and you would say, oh, Jay, you're a master electrician, blah, blah, blah. You hold a ICC electrical inspection inspector's card, whatever. Hey, listen, there's no shame to calling an inspector and having them come out and put their insight on it, because again, you're in their jurisdiction, you're in their backyard. You want to make sure that you're doing it per their requirements, and they may have amendments that are not per the NEC that may be above and beyond. So again, call them up, bring them out, make sure you're licensed, because if you're an apprentice and you're calling these guys out and they card you, they'll shut you down, and they'll shut whoever pulled the permit for you down. So make sure you're doing it legit.
Yep, always do legit. What is it? Too legit. Too legit to quit. Too legit. Okay. Anyway, boy, hammer time. All right. Anyway, so wow, we totally got off of on anything. So, what else have we covered here, Jay? We pretty much done. I mean, obviously there's the labor involved, and you just have to skill, and you can't cover all that. But we've covered pretty good topics here. We've covered how to get down to it. And again, when we talk laterals, that's pretty darn easy, right? I mean, you take all that overhead out of the way. Lateral comes in, comes up to the meter, goes in the meter. Everything from the meter comes in is just traditional. If it comes into the meter and hits a disconnect, because you now have to have the breaker outside per 230/85, then you do it the same way as you would overhead. It's just a difference in which direction it comes from. Any other tips and tricks or anything that you might want to give once they get inside of it? Again, you heard how the timing is a big deal from jurisdictions that I was in. We had to time it to get it done in a day. You have a little more flexibility, it seems, to be able to do this, to get people back in their home anyway. What other things that you can think of? Oh, your aluminum. You like to use aluminum?
Yes.
Use
I
SC?
use aluminum for my service entrance conductors, and I use aluminum for my feeders for my remote distribution panels.
Perfect. I like how he said that, remote distribution. You all thought he was going to say, y'all all know what y'all thought he was going to say. You thought he was going to say sub panel, didn't you? Coach.
Or your subby. Some of my guys say, where's my SDR for my subby, bro?
Subby, bro.
No?
Yeah, it sounds like Colorado. All right. So do you use antioxidant compound on your aluminum at terminations to your panel boards in your lugging? Do you?
I mean, there's guys on the truck that it's all based on who's installing it. Some of my residential guys, my licensed guys they'll just throw it on there because they like it. If I'm doing the install and I have it nearby, I'll probably put a little bit on it. But if I don't have it, then I won't do it.
What do you call it? What do you call it? Do y'all call it Pookie?
No, we call it no loss.
Just No Lock. Well, that's a trade name. That No Locks is Ideal's name. Isn't it got a little gimmicky name? I think we used to call it. I think it was Pookie.
Pookie?
I don't know.
Pookie's that stuff that the mechanical guys use.
No, maybe that's Chico. Maybe that's the stuff that we put when we were sealing a raceway for alarms. For like.
For like explosion proof, like spray paint.
Well, basically, if you have garages and things like that, you have to seal those raceways, and I think it's called Chico, but I can't think of that. I thought Pookie. We used to use the name Pookie was what we would use for the No Locks, Pookie or whatever. Anyway, everybody knows my opinion on it. I've done an episode on it. I use antioxidant compound, whether it's copper or aluminum. It doesn't matter to me. I buy it in the big container anyway. To me, it's all about keeping moisture, and it's all about keeping oxygen away from that conductor, and that's why I do it. Because aluminum and copper both oxidize. However, if you get to it quick enough and you terminate it, you don't leave it sitting there long, it's not so bad. Copper oxidation cracks off very easy. The moment you torque it, it pretty much breaks it up. Aluminum, it's tougher stuff. So if you let it sit too long and it starts the aluminum, here's a key. Look at the end of your aluminum and then look at the side of the aluminum. If it starts to get opaque on the side, but at the end, it doesn't look so bad, then you're starting to get oxidation. And my solution for that is leave the insulation on it all the way up to the end until it's time to use it. And if you're going to leave it for any length of time, like J&M, leave it over, a day is not going to hurt you. But if you do, I would prefer my guys to seal the end of it. Just wrap some tape around the end of it. Just keep them exposed, especially if it's going to rain or do anything like that. Again, it's just little things. But at the end of the day, it's not required to use the antioxidant compound. Okay? 110.14 just tells me that if I choose to use it, it's got to be not detrimental to the conductors or the equipment. And most of the day are all petroleum based, so they're not. Years ago, there was a problem because they'd either have copper flakes in it or aluminum flakes in it. Now they use zinc flakes in it that is actually in it, and it's perfectly fine for use in copper and aluminum. So, but again, unless the equipment tells you to do it, it's optional. I just like to do it. That's just me. Yep. He doesn't. I do. I don't care. Right? You know what I'm saying? But I do work for a wire and cable manufacturer, so maybe I know some inside knowledge that he doesn't. Maybe not.
Well, you'll have inspectors that will require you to do it.
That's a problem then. Do they require it? And why do they require it? Because I use it, right? But the moment that you require me to do it, I'm not going to use it just out of spite. Don't come to me and tell me to use it and the code doesn't require it.
Right.
And if I use it, that's my option. But don't bang it down my throat if the code doesn't require it just because you want to do it because it's the way you did it before you became an inspector. Don't be doing that.
No,
minimum code. Minimum.
This is a good opportunity for the listeners to jump onto your 2020 code program where you go over each section of it. I know I'm kind of getting off topic, but...
No, you mean over on the YouTube channel. So you're listening to this in the YouTube channel, and the 2020 code's coming. It's not going away.
It's here, man.
It's here. It's here in Colorado. Here. It'll be in what is this? November. It'll be in Texas, Massachusetts. It's here. You want to be ahead of the curve. There's some significant changes in the 2020, and so. What Jay was saying is over on our YouTube channel, you have a join button. You can join it for as little as $4.99 commitment. You can get the code changes, or you can be a VIP supporter. And that's just showing your thanks to us for doing it, for me providing the free content that I do. You help supplement the time that I have to put in to the free stuff. So again, I appreciate you. So there's different levels there, but that's what he's talking about. And you get exclusive access to things like our 680 swimming pool videos that are only exclusive to members. They're not exclusive. Nobody else can see them. And the 2020 analysis, which we're getting ready to start back into now on the 215, picking up where we left off.
Yep.
So,
which I've gone over quite a bit. Sorry to cut you off, Paul, but I've gone over it And what's good is Paul's already covered the 210.8, which are the GFCI requirements. He's gone over 210.52 dwelling requirements, receptacle requirements. So this is stuff that we're using now in the field as an electrical contractor. And instead of doing what I've done in the past, and that's show up to a project, rough it in the way that you think is right per the code of your understanding, whether it's something that you've done in the past, or maybe it was an inspector that's correcting you and you're like, oh, well, I've got hit in this jurisdiction for doing this, so I'm going to carry that on to other jurisdictions. Be ahead of the curve and maybe inform your inspectors of what's going on in the 2020 and how come you do stuff. Because a lot of these guys out here, they wait to get hit. Again, I knew about 230.85.1 and I knew about 230.67D, which we talked about earlier that I got hit on, and I will get the stickers to properly complete that installation per code. But be ahead of the curve. Get into that 2020 YouTube channel that Paul has, and don't wait for the inspectors to hit you, and then you're kind of at their mercy. Be ahead of it and be code strong, man. Code strong.
That's what I'm talking about. That's what I'm talking about. So, Jay, I think we probably beat this one to death, and there's really a lot of good info in this one. Hopefully you people that watch this made it this far, because again, if you're that special, unique kind of person that made it a 1 hour and 31 minutes into an Electrician Live episode, then I want you to make sure you walk away with something and you got something out of it. Okay. Also, before we leave, I want to mention you can donate all the goodness that is Electrical Code Academy by visiting our website and making a donation. You can get these nifty little screwdrivers with the little 8 blades in them. Again, you get those, you can donate and you get that. I believe that's $25 donation and I'll send you that. Or a $20 donation and you can get, there you go. There you go. I just got to turn the wrong way anyway, but there you go, right there. You can get these nice little blinking lights. They got magnets, so you can stick them up or whatever, and awesome.
I have it on the right way. You can see my pretty face. See that?
So yeah, I'll do it. I'm liable to do this, and I'll have a seizure or something. All right, so strobing effect. Oh, look at that! He's got his mask. There you go. Wired up, baby.
COVID guys out there. I sent a couple to Paul.
Yeah.
And so these are the ones that I have that have my company logo on them. I sent Paul a few extras for giveaways too, for donations the next few weeks. So get your wired up mask.
There you go. Stay COVID free.
$100 donation minimum. No.
Woo! That's what I'm talking about. Ooh, that'd be like, I might even throw in a screwdriver and a flashlight for that. Anyway. We thank y'all for joining us tonight. Hopefully you got some insight out of this. Again, it's about as much as we can go into. We did go over tonight, so I appreciate you sticking out there with us. Again, till next time, Jay, say goodbye to everybody, Jay. And
you guys have a good week.
All right. Y'all take care. God bless.
To Electrician Live with your host, Paul Abernathy and Jay Grunberg.